Okay, we are going to wrap up section 4.2, in fact, chapter 4 here today, talking about designing experiments. We discussed at the end of the last video about a double-blind and a single-blind experiment, but there's a lot mentioned on the AP test regarding what's called a block design. And this can be a little confusing, so I want to make sure that it's clear what a block design is referring to. A block design is when you have a group of subjects or units and you know what group you're dealing with before the experiment, and somehow that group of people, they're all similar in some way. They have some similar characteristic that you would maybe think that could affect the response variable in some way. Okay, so what happens in a block design is you're still randomly assigning treatments to the units or the units to the treatment, either way, but you carry it out separately within these blocks or groups of similar people. Okay, now here's the key. When you make the blocks of people are not made at random. Okay, now I'll explain this here. Okay, but you keep the similar groups of people together, and it says here the blocks are formed by grouping experimental units that are similar in some way, that you're expecting that similarity to possibly affect what your response variable is. Now, what this is going to do for you, and you'll see this in action here in a minute, is it's going to help us control for those confounding variables, those things that maybe, those outer things that are influencing the response variable that we don't want to impact. So here are some different variables that are often, experiments are often blocked by. We can block by age, by gender, race, achievement level, okay? For example, let's look at an example to see if we can sort of make sense of this idea of blocking, okay? It says a cell phone company wants to test 2 keyboard designs, and we're going to call these 2 keyboard designs Design A and Design B, okay? This is for their smartphone. It says it will use 10 volunteers. Okay, so there's 10 volunteers. Now here's the response variable. The response variable is the typing speed in words per minute. So how fast can someone type with this keyboard design? Okay, it says 4 of these 10 volunteers, they already use a smartphone, but the remaining 6 people, they don't use a smartphone at all. Okay, so they're not used to a smartphone in any stretch of the means. Okay, now here is a little experimental design diagram that would show how we could apply a block design. Okay, it says we start out here with our 10 volunteers. Okay. Now, we certainly could say they're in groups. The groups aren't equal, but they're definitely in 2 distinct groups where this group of 4 has something in common. They all already use a smartphone. This group of 6 has something in common. They don't use one, okay? Now, you would think that these 4 people would likely perform better than these 6 at typing on any smartphone, because they already have a smartphone. These 6 have a disadvantage, okay? Now, you might be saying, why would we want all 4 of these in one group and all 6 of them in another? Well, let's see how this plays out. I'm going to keep all 4 of the smartphone users in one group. We call that a block, okay? So this would be one block, and then the other block, okay, would be, the 6, sorry, yikes, this is getting all out of whack here. Oh my goodness. Okay, and this other block would be the 6 non-smartphone users, okay? Now, the blocks are not the treatments, okay? The blocks are the predetermined groups, okay? You notice up here, I formed them not at random. I formed them based on a similarity that everyone had, okay? And then within this block of 4, what I'm going to do is I'm going to randomly assign half of them. So 2 of them are going to use keyboard A, and 2 of those smartphone users are going to use keyboard B. That way, I have half of the experienced smartphone users using each type of keyboard, and I can compare the results of the groups who are experienced, and then down here for the non-smartphone users, I'm going to also randomly assign so that 3 of those 6 are using keyboard A and 3 are using keyboard B. So it allows me to compare the non-cell phone or smartphone users to each other at both keyboards. And then in the end, I can compare each of those results and combine everything together. But you could see how that would be an advantage of blocking, is you would want to kind of split those groups in half, so within each group, some of each are in each treatment group, okay? Now, a specific type of a block design is called a matched pairs design, okay? Matched pairs. And this is when one of 2 things happen. Either the subjects are paired by matching a common important attribute that they have, or there is like a special, well, this is called a special case for a randomized block design, or where each block has 2 subjects in it, okay? So sometimes the results might be, and honestly, with a matched pairs design, sometimes one person can undergo both treatments, and you're just kind of comparing the results against yourself. For example, maybe you take a pretest, and then you're presented material, and then you take a post-test, and so you are being matched against yourself. That's an example of a matched pairs design, where you're kind of undergoing both treatments, and then you are comparing the pre and the post against yourself there. Okay, another example is if you notice that 2 people are really similar to each other. And this can happen a lot with like twins. If they want to see how twins would respond to certain things, maybe one twin is assigned to one treatment, the other twin a different treatment, and then they compare the 2 twins against one another. Okay. Another example of how an individual could undergo both treatment types is I could have you measure your heart rate while you're standing and then measure your heart rate while you're sitting. Those are the 2 treatments, okay? And then you would, compare those against themselves. That would make more sense than comparing one person's standing heart rate to a different person's sitting heart rate. Okay. Like children, for instance, they have a much faster heart rate than adults. So it makes more sense to compare your heart rate standing and sitting with the same person. Okay. And again, that is a matched pairs design. Okay. So it says here, does a new calculator help students perform better on a math test? There are 10 calculus students who were selected for this study, and we want to illustrate a randomized, but notice it says a randomized block design using matched pairs, okay? So we got to think about how could we pair students up if we're talking about 10 calculus students, and we want to see if this new calculator compared to the old calculator would maybe give them better results, okay? So we could say something like this: the students will be paired by their academic performance, okay, in calculus. So we could take the top 2 students in the class, and it would make sense maybe to pair them up against each other. So we could say the top 2 students will be in one block. So that's going to be our first group. Blocks are just groups, okay, in one block. And one will be randomly assigned to test, let's see. Okay, maybe it's not with an old calculator. Maybe it's a new calculator and no calculator. I'm not sure. That wasn't really very clear. One will be randomly assigned to test with a calculator, and the other no calculator. Okay, so how could we do that? Well, you could say, look, I'm going to toss a coin. And for the first person, they're going to toss it. If they get heads, they get to use the calculator. If they get tails, they don't get to use the calculator. And then the second person doesn't even need to toss the coin because they're just going to automatically get that other treatment, okay? And then we just say the other student in the block is automatically assigned the other option, okay? This random assignment is repeated for the next two students who are paired by ability level. Okay, and then I'm just going to put etc. So we know, like, then we do the next two and the next two. And then we're just going to say after the test, we want to compare the results within each block, then combine the results, meaning there'll be 5 blocks and then we'll kind of combine all 5 blocks together then, okay? Okay, so the next example, it says here, women and men respond differently to advertising. Researchers would like to design an experiment to compare the effectiveness of 3 advertisements for the same product. Explain why a randomized block design might be preferable to a completely randomized design for this experiment. Okay, so let's look at this part here first. Okay, now here's the difference. If it's completely randomized, everyone is all in one gigantic group, and you just start randomly splitting them and assigning them to treatment groups. If it's a block design, you purposely put them in groups first based on a similar characteristic, and then within those groups, those blocks, then you split them in half, randomly assigning them to treatment groups within the block, okay? So we could say for part A, since women differ from men in their response to advertising, it is best to block by, and what variable would we want to block by? We would want to block by gender. Okay, we would want to block by gender. This is going to allow women's responses to be compared to women and men to men. Okay, because we're going to split half the women in half, and they're going to watch, or in thirds, I guess, and they're going to watch, a third of them will watch advertisement A, and a third of the women will watch advertisement B, and then a third C. And you can compare the women's responses to other women, okay, which is going to be more valuable than throwing everybody in a pot and maybe through random assignment accidentally having some men and women be a little, in the groups, be a little bit disproportionate there, and then you're not sure if the results of that group were because there were a bunch of men in it and they just tend to lean one way. That's what blocking does, is it allows you to kind of remove that one variable at play there, okay? And so I'm just going to end with this for part A. This will help determine how effective and add may be by eliminating the difference in gender reactions. Okay, that's really, really good communication there to kind of add that there on the end. Okay, now part B says, outline a randomized block design using 300 volunteers, 180 men and 120 women as subjects. Describe how you would carry out the random assignment required by your design. Okay, this is where sometimes students are just not detailed enough. You need to think that whatever you're going to write up for your plan, you could hand it to someone who maybe didn't know a lot about statistics and they could execute your plan. Okay, so we want to say that we're going to group 180 men. We could say something, there's a variety of ways you could talk about getting them to split randomly into these 3 treatment groups for the 3 ads. I'm just going to say, put their names in a hat on identical slips of paper, pull out, now I want a third of the 180, so pull out 60 slips, oops, okay, 60 slips, and assign them to watch ad number 1. Okay, and then I'm just going to say the next 60 will watch ad number 2, and the last 60 will watch ad number 3. Okay, now when I go to explain how I'm going to do this with the women, let's see here. I'm basically going to do that same thing here, only I'm going to change this so this says group the 120 women, put their names in a hat, and I'm picking out 40 for ad A, 40 for ad B, and 40 or for ad 1, 2, and 3. Sorry. Okay. And in the end, I should probably say that that I want to combine all results. Okay, combine all the results. Okay, so the idea is you want to try to control what you can. You want to block whatever it is you can't control. Like you can't control the reactions of men and women, but we can block by them so that that's not going to impact it as much. And then we want to try to always do that random assignment of treatment groups. Okay, the last page in this particular notes page is just having us revisit this super important idea of what conclusion can you draw based on the design of the study. One thing that you are going to see a lot is you're going to see the statement, the results were or were not statistically significant. If the results are statistically significant, that means that you were able to conclude that your explanatory variable was actually causing the response variable. Okay, so statistically significant means that the explanatory variable caused the differences you're seeing in the response variable. Okay, underneath here, this is very similar to the chart that was on the front page of this notes here. Okay, we want to be looking for, was there random assignment to treatment groups, and were these individuals selected randomly for us to kind of fill these blanks in here. So let's run through these last few very quickly here. It says many students insist that they actually study better when listening to music. A teacher doubts that this claim and suspects that listening to music actually hurts academic performance. Here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the semester. Suppose that the average or mean GPA for students who listen to music while studying was significantly lower than the mean GPA of students who didn't listen to music while studying. Okay, so we're saying if you listen to music, you had a lower GPA. Okay, at least lower than those who didn't listen there. Okay, what can we conclude for each design? Okay, so let's see how this was designed. They said they're going to get all the students in your AP Stats class to participate in this study, and you're going to ask them whether or not they study with music on, and then you're going to divide them into 2 groups based on their answer. Okay, so, if 10 of you say you study with music and 5 of you say you don't, those are the 2 groups. By the way, you don't always have to have the treatment groups have identical amounts of people in them, okay? That they can be uneven, and that's all right, okay? But let's go ahead and answer here. Random selection, yes or no? Well, no, that's not random selection, because this was asking about seeing whether this was the case for the students in general at your school, and you are limiting it to asking only the stats students. So we're not randomly selecting students at this school. We're picking everybody in stats class. So since we did not do random selection, we can do no generalizing to the population, meaning the whole population in the school, okay? Were treatments randomly assigned? No, there was no random assignment. Remember, we just asked people, what do you do? And then that put them in their group. So that means there can be no cause and effect conclusion. So how could we tie these 2 pieces together then? We would say something like, well, there might be a relationship between these. So we could say, well, there is an association between listening to music while studying and semester GPA. Okay, so association means that we didn't randomly assign, but we can't say it for all students at our school. We just have to say for all AP Stats students in this class. Okay, very limited to what conclusions we could draw there. Okay, what about if we designed it this way? You select a random sample of students from your school to participate in the study, and you ask them whether or not they study with music on, and you divide them into the 2 groups based on their answer to the question. Okay, now this feels like we can say yes to random selection, still no to random assignment, but since we said yes to random selection, that means that we can generalize to the population, but still no cause and effect conclusion. Okay, so our write-up would look something like this. There is an association between listening to music while studying and semester GPA. But instead of saying for all AP Stats students in this class, I can say for all students at the school. Okay, what if we organized it this way? What if we said that we're going to get all the students in our AP Stats class to participate in the study, then we're going to randomly assign half of them to listen to music, so they get that treatment group, and the remaining half have to abstain from listening to music. They have to not listen to music, okay? Well, that sure sounded like we randomly assigned them to treatment groups, but again, we're not randomly selecting them from the student body, so no generalize to population, but we can conclude cause and effect, okay? Cause and effect. So our write-up for this would be, there is a cause and effect relationship between listening to music while studying and semester GPA for all AP Stats students in this class. Okay, and then finally, what if we organized it this way? We're going to select a random sample of students from your school to participate. We will randomly assign half to listen and the remaining half to abstain. This was a yes to both, so we can generalize to the population and we can conclude cause and effect. So this is going to be, there is a cause and effect relationship between listening to music while studying and semester GPA for all students at